Hi everyone, what we're going to do today is create a system to recall your switch configuration automatically after resetting it. The idea is that if you're a rental company, you can rent your switch and let people modify every setting in it, and then don't spend 20 minutes per switch resetting everything to your working configuration. So we want to have as less manipulation as possible. So we're going to need a few things, a switch obviously. I'm using a Cisco SG300, it's a 10-port PoE, but our system will work for any SG300 or 350 switch. We're gonna need a Raspberry Pi. Again, I'm using a Raspberry Pi 4 because that's the one I got at home. But it can work with any Raspberry Pi you got. It can be the 3, the 3B or the 0 watt, whatever you got. And you will need a computer, a PC or a Mac. We'll use it mainly to burn the SD card and then control the Raspberry Pi over the network. You can do all the manipulation directly on the Raspberry Pi if you have a screen, mouse and keyboard. I will be using MobileXterm, it's a terminal software, so it will be easier for me to record the steps I'm doing, but you can do all the terminal configuration directly on the Pi. Also, disclaimer, I'm gonna dub the next part of the video because I previously shot the video in French, and it's easier for me to put English audio over it, as I already did the editing for the French part of the video. But don't worry, every command and steps are the same. So let's explain what tool we're gonna use. First, we will use a Dhcp Server. It's a system that automatically sends IP address on your network. The package we will use is isc-dhcp-server. It's a free package for Debian, but we'll use Raspbian. Secondly, we're going to use a Tftp server. Tftp is for Trivial File Transfer Protocol, and it will allow us to simply transfer our configuration file on the network. So basically, the Raspberry Pi will send IP address through the Dhcp server and the configuration file through the Tftp server. So let's start by burning a Raspbian on an SD card. I will use Raspberry Pi Imager. It's the official software for Raspberry Pi. It works very well, so I suggest you use it too. You choose the OS, the SD card, you press write, and then you wait for the software to write and check the SD card. Once you're connected to your Raspberry Pi through SSH or VNC or whatever, the first thing we're going to do is set up a static IP address. So we're going to modify the network configuration file of the Pi with this command, sudo nano /etc/dhcpd.conf. By the way, I will post every command on the file into the description, so it will be easier for all of you to remake this tutorial. So this file will allow us to configure all network interface of your Pi. We're going to add this line at the end of the file. So interface ETH0 means that our setup will concern only the wired interface of your Raspberry Pi. So static IP address is 192.168.67.23. So obviously it will be the IP address of the Pi of this interface. I use a .67 network because my local network is in 66, but you can put any address you want as long as it makes sense through your network. And the /24 is to get a free time 255 network mask. So the static router will be the Pi itself, and the DNS will be a Google server. So we save this file, and now our wired interface will have a static IP address. So now we're gonna install the two packages we just spoke about. So the Dhcp server and the Tftp server. We start by the classic sudo apt-get update to update all the packages available to download. And then we install the Dhcp server first with this command. Sudo apt-get install isc-dhcp server. And we can see that we directly get an error message. So we could think this is some problem with our install, but it's not. The server cannot start because we haven't configured it yet. So let's do that by edit this configuration file. So sudo nano etc dhcp dhcpd.conf. So we are on a big document with a lot of commented part that are possible configuration for your Dhcp server. So we're gonna create our own Dhcp range. That means that our server will give addresses between this address and this address. It will give this address as a default router, and the net mask will be this one for everyone. So let's add some line at the end of the document. So subnet 192.168.67.0, my subnet will be the .67, a net mask with free time 255, and the range will be between 6760 and 6790. As the option router, we set the Raspberry Pi addresses, so 192.168.67.23, and the DNS will still be the Google server. So we're gonna save that, we just have to restart the daemon with this command. Right now, we got an error message. That means something is wrong with our configuration file. We can see right there, line 113, unexpected end of file. What is going on in my file? The error is that I just forgot a bracket at the end of the file. I've been through a lot of these errors while doing my tests, so I thought I would show you a bunch of these in case you get in front of them at some point. So let's start our server again. It seems to be working fine. It can see that we didn't configure anything about the .66 subnet, which is the subnet I'm connecting on through my wireless interface, the WLAN 0. We can also see that we get a no subnet declaration for ETH0. That's a problem, because we just set up some settings for that. The main reason you could get this message is because you started your server before plugging your RJ45 cable into your interface. If you didn't plug in before, you will have this annoying message not configured to listen on any interface. So that means that your server won't work. So let's start the server again now that our cable is plugged in. And now we can see that the server is listening on a wired interface ETH0 and it's sending some IP address on this interface. That means that our server is fully working. So now let's install our Tftp server. We'll use the package tftpd hpa. So sudo apt-get install tftpd hpa. When it's done, we have to configure it. So we're gonna edit the tftpd hpa files. It contains different variables. So let's modify this tftp directory variable. It will point the place in your drive where you will put your Cisco configuration file. I decided to create a folder named Cisco file where I'll put all my config files. So this folder is located into my user folder. Into the variable, we'll have to put only the path to the user folder. So /home/p. The following part of the path will be written in another file we'll see later, where we'll create a link between the switch and its configuration file. So the second thing we have to modify is the TFTP option line. We have to add a -v. It means verbose. It will make our server log more clear, so we will be able to see who requested a file and if it got it well. So now our two servers seems to be configured, but we have to do one more thing. It's to write somewhere into our Pi that our switch has to get its config file somewhere. Thankfully, we can add this option into the Dhcp Server configuration file. So we're gonna add some other line. It will start with switch 1. Into the bracket, we have the MAC address of your switch, which is located right here on your switch. If for any reason you don't have this sticker on your switch, you can still find your MAC address through the web interface of the switch. So you have to add your proper MAC address, and then into file name you have to type the path to your configuration file. I've got my Cisco file folder that I created before right here, and I put my file switch_1.txt into it. Be careful about the path, because if you make any typo, it won't work. So for my example, you will have file name Cisco file -switch_1.txt. You save your file and now everything is ready to work. We'll just need a reboot of a Raspberry Pi, so sudo reboot, and now we wait for the Pi to start again. We will restart the two services, the Dhcp and the Tftp server, and our switch will be able to automatically find its configuration file after we reset it. So now let's start off the Dhcp server. We can see that it's listening on ETH0. We restart our Tftp server, and just to be sure, we use this command to check if our services are running fine. So sudo service dhcp-cd status and sudo service tftpd hpa status. We can see into the active line that the service is running, and for the Dhcp it's running too. So now we'll have to plug our switch to a Raspberry Pi and reset the switch. So we plug it, and then I will use this little nail to reset it. We have to wait something like 20 seconds, I think. Every LED are blinking, so we can drop the nail, and now we wait for the switch to find its configuration file. We just saw all the LED blinking again, so that means that the switch just found the configuration file and is applying it. Now we have to wait until the LED on the left of the switch is not blinking anymore. By the way, if you didn't know, this LED blinking can mean different things. 1. The switch is looking for an address on the network. Or 2. The switch got its default address, which is 192.168.1.254. So now we can see our left LED stop blinking. The switch applied the configuration file it found. My address was 192.168.67.222, and when I ping, we can see that the switch answered. So he found the whole configuration. I'm gonna connect to it through the web interface with my PC, which got an IP address from the Dhcp server on the Raspberry Pi. So it's 192.168.67.62. And now if I put my switch IP address into my web browser, I can access it, and all my VLAN I created before are here, so our system is working fine. Now we have a final step to do. It can be complicated if we have to restart both services every time we reboot the Raspberry Pi. So we're gonna write a script which will start all these commands at boot. In your Pi you have some file that automatically start at boot, like the rc local file. So we're gonna add some line at the end of this file. Everything that is located before the exit 0 at the end will be run at the boot of the Pi. So we're gonna add this. Sleep 10, that means that the Pi will wait for 10 seconds before running the next line. This way we can be sure that our Pi network settings will be ready before we ask them something. I told it to run the Dhcp server, and then I told it to run the Tftp server. So that's it. So now we save our file, we reboot the Raspberry Pi and the switch at the same time. So sudo reboot and neg reset. That's it. And now we wait for the switch to finish its reset. That's it. And he found the config file and he will apply it. And now my switch finished to apply its configuration file and it's working. So we have a setup that can work on its own, without a screen, without a mouse, and without a keyboard. You only have to plug the switch to the Pi, you start both of the machine, and you reset the switch. Be sure to plug everything before you turn it on. It will not work otherwise, because the processes won't start. You can now set up 50 switches at once if you need to. You can just plug the Pi into a non-manageable switch, and link every other switch to it, and the configuration file will spread through the network, and your whole system will be ready to start working again. That's it for today. I hope you like this tutorial. Don't hesitate if you have any question. I will be glad to help you figure out some problem if you have. Every comment are in the file into the description. I hope you liked it. See ya!